Hello, good morning to everyone. Myself, Dr. Mahadev Unde, Professor in Electrical Engineering Department, Zeel College of Engineering and Research, Pune. In this video lecture, we are going to learn what is the short circuit ratio of the alternator or a synchronous machine. Now, this short circuit ratio has a paramount importance as far as machine design, operation is concerned. Now here, look at this. To find the short circuit ratio, it is necessary to have the two tests, that is the open circuit test and short circuit test. Once the tests are conducted, we have to plot the OCC and short circuit characteristics. So on the x-axis, we have to consider the feed current, and on y-axis, open circuit voltage generated per phase. So in this way, here we can plot the OCC, that is open circuit characteristics, and here it is observed that the feed current required to generate rated open circuit voltage is OA. OA is the feed current required to generate the rated open circuit voltage per phase, that is AC. Similarly, we will plot the graph or the short circuit characteristics, that is the feed current on the x-axis and the short circuit current per phase on the y-axis, and the short circuit characteristics is nothing but a straight line passing through the origin as shown. Now here the D represent the rated armature current equal to the short circuit current, and the feed current required to circulate short circuit current equal to rated armature current is nothing but OD. Thus, we can define the short circuit ratio is nothing but it is the ratio of feed currents. So what is it? The feed current required to generate open circuit voltage per phase divided by feed current required to circulate rated short circuit current per phase. So what is this voltages? What is the rated open circuit voltage? AC represent the rated open circuit voltage per phase, and DE represent the rated armature current equal to the short circuit current per phase. Thus, the SCR can be defined as the SCR equal to, pay attention, SCR, the numerator is the feed current, it is the ratio of feed currents. So what is the feed current required for the numerator? The feed current required is OA. OA is the feed current required to generate rated open circuit voltage per phase divided by OD. OD is the feed current required to circulate rated armature current equal to the short circuit current per phase. Now pay attention, this SCR equal to OA upon OD. But we got two triangles here. The small triangle, or it is a triangle in triangle, the last triangle is OED and small triangle is OBA. These are the similar triangles. Having the common base. Now see, the SCR is a ratio of OA upon OD. OA upon OD, that is the ratio of the base of smaller triangle to the base of bigger triangle. And according to the corollary, side angle, we can write this ratio equal to the height of a smaller triangle, that is AB, divided by height of the larger triangle, big triangle DE. So once again, SCR is nothing but OA upon OD. OA is a base of smaller triangle to the base of larger triangle, and that is equal to height of a smaller triangle, that is AB, divided by height of a larger triangle DE. Now this is equation 2. Now see, it is repeated, the plots OCC and SCC is repeated in order to have a better understanding. Now SCR equal to OA upon OD equal to AB upon DE. Already we have studied this one. Now what is the XD, that is direct axis reactance, or this can be obtained similar to the synchronous impedance. Say for a larger machine, the armature resistance is neglected, and therefore instead of ZS we can find out XS, synchronous reactance, and that is say the XD, that is the direct axis reactance per phase, and this can be obtained similar to that one. That is, this XD is nothing but AC, that is the rated open circuit voltage per phase divided by the short circuit current per phase, both at the same feed current. That is for OA. For this OA, how much is the rated open circuit voltage per phase? That is nothing but AC divided by the feed current divided by short circuit current per phase at the same feed current, that is AB. So this is the XD, that is AC upon AB. It has been obtained from this line. Okay. Then what is the per unit impedance or per unit reactance? Per unit reactance equal to or actual value to the base value. If it is per unit current, actual current to the base current. Per unit impedance, actual impedance value divided by base impedance. Okay. So similarly here X pu equal to X actual divided by X base. Now what is the X base? X base equal to, pay attention, X base equal to AC. AC is nothing but rated open circuit voltage per phase divided by rated short circuit current per phase or rated armature current per phase. Rated armature current per phase. So X base is equal to AC upon DE, and therefore the X pu equal to X pu equal to AC upon AB. AC upon AB is the actual value divided by base value. Base value is AC upon D, but it is divided, so it can be written as D upon AC. Okay. Thus AC cancel and remainder is D upon AB. This is equation 4. But SCR equal to, what is SCR? SCR is nothing but AB upon D. So AB upon D, this can be written as 1 upon D upon AB. So this is equal to 1 upon X du per unit. Thus we can say the short circuit ratio is inversely proportional to the X pu. So the short circuit ratio is inversely proportional to X pu, that is the direct axis reactance per unit value. And now what is the significance of this short circuit ratio? See the significance. If the short circuit ratio is higher the short circuit ratio, that means the reactance must be less. Higher the value of SCR means lower the X pu. And lower the X value, the reactance is lesser, better is the voltage regulation, because lesser will be the voltage drop across the reactance. Better will be the stability of the synchronous generator. Then better is the power transfer capacity, because power transfer is nothing but EV upon X into sine delta. So the power transfer capacity increases if the lesser the value of X. So higher the SCR, higher will be the better the voltage transfer capacity, and as X is less, as the reactance is less, higher will be the short circuit current. Higher will be the short circuit current, because this short circuit current has to be limited by this reactance, and there will be a large size of machine. The large size of machine, more material is required, more will be the cost. That means, in other words, higher the value of SCR, larger will be the size of machine, more material will be required, and obviously the cost will be higher. And how it can be? See the interpretation of this. The SCR, already we have learned, the SCR is inversely proportional to the X, and the X is nothing but 2 pi FL. So we can say the SCR is inversely proportional to the inductance. But inductance equal to N square upon S. N square upon S. So we can say 1 upon L is directly proportional to the S, that is the reluctance of the air gap. Reluctance of the air gap, and reluctance of the air gap is directly proportional to the length of the air gap. Length of the air gap. And where this Lg is nothing but, Lg is the air gap between the stator and rotor. So larger the length of the air gap, the more will be the MMF required to pour the same flux. And in order to have more MMF, number of turns increases, height of the pole increases, and as the height of the pole increases, obviously the size of the machine increases. As the size of the machine increases, it will require more material, and obviously its cost will be higher. So in this way, the SCR affects all these points. Okay. Now let us turn how the SCR affects, means lesser the value of SCR, what will be its effect. So lower the value of SCR, that means higher value of XD per unit value. That is, XD is nothing but a reactance. Okay, therefore higher the value of reactance, poor will be the voltage regulation, because there will be a large IX drop. The voltage drop takes place across the reactance will be large, and therefore the voltage regulation will be poor. Then another factor is higher the value of X reactance, wide range of excitation current is required. Means feed current required will be a wide range of feed current is required to maintain the terminal voltage on load. And that means more feed current is required. Okay. And it has a poor stability of the synchronous generator. And the power transfer capability will also reduce. So this is the significance of the SCR. Okay. Now what are the typical values of SCR for different types of the machines? These are shown as shown in the figure. Now say for the cylindrical rotor machine, the value of SCR lies between 0.5 to 0.9. Means for the cylindrical rotor machine, generally it is less than 1. Whereas for the salient pole machine, it lies between 1 to 1.5. And for a synchronous condenser, synchronous compensator, its value may be up to 0.4. So in this way, we have finished what is the short circuit ratio and its significance. We'll stop here. Thank you very much.